Today, we're going to look at the cross product, which is a vector product. It's a way of multiplying two vectors and coming up with another vector. There are, as usual, two things that we need to do. How do we make this calculation, number one? And number two, what does this calculation tell us? Because once we have that, we can see possibly the uses of this particular calculation. I'm going to start with what the cross product tells us. So the cross product is a vector product. We'll say V cross U. So we're multiplying, but the product is going to be a vector. Remember yesterday we mentioned that two vectors if we have any two vectors that are not collinear, those vectors will be sitting in a plane. Those vectors will define a plane. So I got the vector U and I got the vector V. Those vectors are defining a plane. Also note that my vectors are in R3 because they have three component pieces. So the vector U and the vector V are defining a plane in R3. The cross product of U and V is going to be a vector that is perpendicular to both U and V. So this is one of the important things that we get from the cross product. V cross U is going to be a vector perpendicular to both V and U. So this V cross U is going to be perpendicular to U and perpendicular to V. I picked a pretty unfortunate angle between U and V. As I usually. So notice that I drew a vector that is perpendicular to U and V, and I take this particular direction. And you may notice that there is another direction. Because the vector that goes down, that points down, is also both perpendicular to U and V. So we have two choices for this vector. In this picture, the vector that points down will be the vector U cross V. And so we've come across something interesting to note about this particular multiplication. First of all, it is a multiplication. We're calling it a cross product. But what we just seen is that the cross product, even though it's multiplication, is not commutative. V cross U is not the same as V cross V. So notice that V cross U is not equal to U cross V. The cross product is not commutative. For a lot of people, this is the first multiplication that we come across that's not commutative. Normally, A times B is equal to B times A. But in this case, the cross product is not commutative. The V cross U is not equal to U cross V. If you've been through linear algebra, you may have seen before that matrix multiplication is also not commutative. A times B, when A and B are matrices, A times B is not necessarily the same as B times A. So we say it's not true in general. It's true for some pairs of matrices A and B, but it's not true in general. cross product is not commutative. V cross U is not equal to U cross V. But it is predictable. V cross U will be -1 times U cross V with a point in the opposite direction. If I multiply a vector by -1, by the scalar -1, that just makes it point in the opposite direction. Maintains a magnitude, reverses the direction. The way you determine which direction the cross product points is what's called the right-hand rule. You determine which direction the vector points according to the right-hand rule. So the direction of the cross product will be determined by the right-hand rule. You put the fingers of your right hand pointing in the direction of the first vector that's listed, and you curl your fingers toward the shortest distance, or the smallest angle towards the next vector. You take the shortest path, you curl your fingers to the shortest path of U. So to find V cross U, I would point my fingers in the direction of V and curl them towards U the short way. And then the direction of your thumb will indicate the direction of the cross product. So we can see in this example, the short way from U cross V has V cross, for V cross U, we point in V and we curl towards U, and that's why the vector points up. If we calculate U cross V, I would point my fingers in the direction of U and curl my fingers the short way towards V. And then that's where we see that U cross V will point back. The fingers in the direction of the first one, curl in the short way to the second one. Any questions? Here's one of the reasons that we might care about finding this vector. Notice that the cross product will always be perpendicular to the plane containing the two vectors. So U cross V is perpendicular or normal to the plane containing U and V. U cross V is perpendicular or normal to the plane containing U and V. U cross V is perpendicular or normal to the plane containing U and V. Like I mentioned a couple days ago, two vectors that are not collinear define a plane. The consequence of this is that we can define a plane with one vector. Instead of saying the plane containing the two vectors U and V, we can define a plane by saying it's everything that is perpendicular to the normal vector. It's a way to describe a plane with one vector. So the cross product introduces us to describing a plane with one vector. So this is going to allow us to describe a plane in R3 with one vector. If I say the vectors u and v are forming a plane, we can describe that plane with u cross v by saying everything perpendicular to a normal vector. So we would describe it by saying everything perpendicular to the normal vector. We can describe a plane with two vectors. We can describe a plane with just one vector. That's a big increase in technology. This works really well in R3 because we've only got 3 to work with. If you build a plane, that's 3 dimensions to work with. When we think of a plane, that takes up 2 dimensions. There's only 1 dimension left. And so it's pretty straightforward. If we're in R4, and we have 2 non-collinear vectors, that's defining a plane, but there's 2 more dimensions that are out there. Or if we just pick one vector and say everything that's perpendicular to this vector, if we're in R4, that leaves 3 dimensions left, so we're not defining a plane. If we got 4 dimensions, if I use one of them to describe the vector, everything perpendicular to one vector will be a 3-dimensional space, 3-dimensional subspace of 4 dimensions. But in R3, this is pretty easy. Rather than describing a plane with 2 vectors, which we might want to, a plane that we might want to describe because it's, say, tangent to a surface at a point, we can just describe that plane with one vector by saying everything perpendicular to this one vector. Okay. Now we've got to figure out how to calculate this cross product. We talked about what the cross product is, represents. Now we need to learn how to calculate it. Really inconvenient. My presentation desk is, in fact, the smallest surface in the room. I guess these desks are smaller. But if I was using one of the desks that y'all were using, it wouldn't be shoved up against the wall, so I'd be able to open up the notebook and not have it slide all down. What are you gonna do? So you want to calculate the cross product. The cross product is calculated with a determinant. So the cross product of the vectors u and v is going to be the determinant of a 3 by 3 matrix. Along the top row of this matrix, you put the vectors I, j, and k. The second row of this matrix will be the components of u, whichever one comes first. So u1, u2, u3. And the third row will be the last vector, v1, v2, and v3. So to calculate the cross product, we want to find the determinant of the matrix, where the first row is I, j, and k. The second row is the first vector in the product. The third row is the third vector in the product. We're going to expand this determinant along the first row. We're going to expand this determinant along the first row. Just like with any determinant, we can use any row or column. The first row is going to be the most convenient. If we went around the third row, I would still have to sort out the I, the j, and the k. So I have to hit it with the algebra stick for a little while until I got terms of I, j, and k. And we're going to use cofactor expansion. We're going to calculate this 3 by 3 determinant using cofactor expansion. So the first term is going to be the I term. I'm going to start in the first row, first column, where the I is. And I'm going to multiply I by its minor. So the minor determinant is what's left over if we take out the first row and first column. I sits in the first row and the first column. So if I take that out, I multiply I by the determinant of what's left. So the first term is going to be, oops, I wrote determinant, so this should be matrix notation. When we put a matrix in absolute values, that's usually a shortcut notation for writing for the determinant. Okay, I multiplied by the 2 by 2 determinant, v2, v3, v1, v3. When we're calculating determinants, we start in the upper left with positive, and then we alternate signs. So the j term is negative, so minus j times the determinant. Now I'm going to take out the row and column that j sits in, and that's going to leave me with the 2 by 2 u1, u3, v1, v3. And then we'll go to the k hat term. We're alternating sign, plus, minus, plus. So we're back to being plus. And we write the minor determinant, which is going to be u1, u2, v1, v2. Remember that this is supposed to return a vector, and that's why we need to introduce the I, j, and k into the calculation. Now we just need to calculate all the minor determinants. And we do that by multiplying down the main diagonal and subtracting the off diagonal. So this first minor is going to be u2 times v3 minus u3 times v2. So the first term in our cross product is going to be U2V3 minus U3V2 times I. The next term will be U1V3 minus U3V1. And then the K term will be U1V2 minus U2V1. And that will be the coefficient of K. There's a lot of patterns that are running around here because we don't want to have to set up this 3x3 matrix every single time. We want to be able to just write down what the determinant is going to do. What we definitely don't want to do is try to memorize this. I mean, you can. It's better just to remember it, but you can try memorizing it if you want. I don't know. I don't particularly like memorizing things, so just try to remember it. But there are a lot of patterns that are available. Notice that I, the coefficient of I in the cross product only involves U2, U3, V3, and V2. Also notice it's always a U and a V, and the subscripts never match. So there's no U1 and V1. I get U2 and V3, U3 and V2. So the subscripts never match. Since J is in the second column, there's not going to be any U2 or V2. I'm going to make products of U1, V3 and U3, V1. The subscripts never match in any of the scalar products. And then K takes out U3 and V3. So I'm going to have U1 and V2 minus U2 and V1. To remember which one goes first, if you keep the second term negative, the first term starts with the smaller one, U2 V3 minus U3 V2. U1 V3 minus U3 V1. And then the third one is U1 V2 minus U2 V1. Starts with the smaller of the U's. Now, the other way you'll see this written is multiplying through this negative, and then this middle one becomes different. It looks like U3 V1 minus U1 V3. That doesn't fit the pattern in the other ones. But instead of remembering that there's a negative out in front of the J, if you multiply that in, the second one is here. So at whatever way you're going to remember this, the second one is always going to be weird, either because it's got a negative or it's U3 V1 that goes first. So what I mean is if we multiply by the negative one, this will look like plus U3 V1 minus U1 V3. I guess at least this way they're all positive. But I don't like that second pattern like in the first. So you can see which way I remember it. Need to point these out because I don't know how you remember things. It's different for everybody. Like sometimes people remember your trig functions, your trig ratios by remembering SOHCAHTOA. Did anybody learn SOHCAHTOA? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Another way to remember it is to always put it in sine, cosine, tangent order. Then you can just remember, oh heck, another hour of algebra. Oh heck for opposite over hypotenuse, another hour for adjacent over hypotenuse of algebra for opposite over adjacent. Anybody ever heard that one? I don't know why that one is always new. Everybody goes with SOHCAHTOA. I don't go with SOHCAHTOA because I learned SOHCAHTOA and it was the 80s. So clearly I was given the racist version. That was really annoying because I knew it then. Like, well, what's wrong with you that you would explain that? Especially because SOHCAHTOA. You can just imagine yourself taking your toe and soaking it in water. By SOHCAHTOA. Just go with that visual. But no, I had to get the racist one because 80s in America. So. Or you could use the mnemonic device that I use to remember my trig ratios. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. That's the one that I might not be the most creative person. Yeah. Any questions? So here's how we can calculate the cross product. This is determinant. It's a bit of a mess, but there's a lot of pattern that's running around. We're just calculating a determinant. Those of you who've been through linear algebra, when I said we calculate this determinant, you're probably thinking, oh no, not determinants. And I was like, oh yes, determinants. But it's always going to be this result. It's always ijk, first vector, second vector. How's everybody okay? Right. So let's suppose we have two vectors. U is going to be 2, 0, -3, and V will be -1, 4, 0. What we will want to do is be able to calculate U cross V and then verify the claim that U cross V is perpendicular to U and perpendicular to V. So we want to be able to calculate U cross V. And then we should also check to make sure that U cross V lives up to what we said it was going to be. We're going to want to show that U cross V is perpendicular to U and perpendicular to V. Fortunately for our heroes, yesterday, we learned a very simple way to do that. It's the dot product. The dot product of a pair of vectors is the product of the magnitudes of the vectors multiplied by the cosine of the angle between them. And if the angle between two vectors is 90 degrees, then the cosine of that angle is 0, and therefore the dot product is equal to 0. So the way to figure out if vectors are perpendicular is to show that u cross v dot u is equal to 0. We can use the dot product to show that vectors are perpendicular. Any questions? I don't know how well you can take that information at the top and imagine a 3x3 matrix. I don't know how you prefer to combine a bunch of symbols. Personally, I have to organize them into a matrix, otherwise I can't do the problem. I can't just go from the stuff on top and imagine it like the stuff, the 3x3 matrix, and then write it down. I also can't just remember what the cross product formula is and write it down based on the entries in the two vectors. I don't know why that is. I can only establish a workaround for it. And my workaround is writing the matrix. So my I component is going to be the determinant of the 0, -3, 4, 0. So that's going to be 0 times 0 is 0 minus a -12. The next term is going to be the j, and that's going to be negative because determinant, and the way I remember it. So I'm going to take out this middle one. 2 times 0 is 0 minus -3 times -1, which is +3. So the determinant is 3, but it's the j one, so it gets negative. So minus 3j. And then the k determinant. Cover up the k. 2 times 4 is 8, minus 0 is 8, so minus 8k. So we've made the calculation. We should check to see that this is correct by finding the dot product of u cross v dot u to see if it's perpendicular, or to see if I've made a mistake in my calculation, which is highly probable because there is a lot of multiplication and I'm not very good at arithmetic. So let's take u cross v dot u. So that's going to be 12i minus 3j minus 8k dot 2i plus 0j minus 3k. So I just multiply the corresponding components. 12 times 2 plus -3 times 0 plus -8 times -3. So I get 24, but then this is plus 24. So where am I off? Oh, this is positive. And now it works. 12 times 2 minus 3 times 0 plus 8 times -3. Now it works out to 0. Now that I've got the right coefficient of k, I can check u cross v dot v. I'll have negative 12. Let's see. I'm getting negative again. What's going on? Negative 12, negative 1, 2, 3, 4, and 12. So the j is going to have 2 times 0 minus a negative 3 times negative 1. So it's going to be 2 times 0. I did a different color. So it's 2 times 0 minus a negative 3 times negative 1. So it's minus a 3. So this should be a plus because it's minus and minus. Thank you. Incidentally, every semester, I set up a cross product to calculate, and I always tell myself, don't calculate it, make them do it. No, don't calculate it, make them do it, you're gonna mess it up. You're gonna drop 2 signs. And then I'm like, oh, the 2 signs will cancel each other out. And it's like, oh, no, they won't. Remember last semester? And I'm like, oh, it will be fine. And then this happens. So, thank you. Don't trust me to do calculations. Here's the other reason that you shouldn't trust me to do calculations. Let's suppose, but this is what's going to happen when you become mathematicians. This is what happens. You go out to dinner with your friends. What happens when the bill comes? They hand it to you. You're the mathematician. You do it. I'm like, oh, everybody at this table has passed 4th grade math. Why are you handing it to me? But it's fine. Here's how you deal with that. You go out to dinner with your friends. You're the engineer or mathematician. The bill comes and they're like, oh, let's hand it to our engineer or mathematician friend. So let's suppose that there's 4 of these. And the bill with tax and tip, because tip your servers, works out to $100. How much does each person put in? If you thought 25, that is absolutely wrong. $33.33. If anybody asks, say, oh, don't forget the tip. That almost always works. Here's why my friends don't hand me the bill anymore. I did that a bunch of times. I go, Leach, it's $100 and there's 4 of us. It's not 25 each. I go, no, because you handed me the bill. I'm a professional. $8 service fee. They're like, oh, but we could have divided by 4. And I'm like, oh, now don't you wish you did? So the important thing to remember is that you need to charge for your services. You're providing a service. Charge your, even though they're your friends, charge for your services. If your friend happens to be a plumber and they got to replace a bunch of stuff in your house, you're gonna expect them to charge you for it, right? So, needless to say, they don't hand me the bill anymore. They're like, well, how long have you been getting away with this? And I'll be like, well, how long have you known me? I go, well, I guess we learned our lesson. I said, well, y'all do know that I'm a teacher, right? You're welcome. You know what I'm talking about? Okay. I'm just kidding. That's not how it works. Because just dividing the bill by the number of people is a couple of stages up in the income ladder of things. Like back when we were all poor, we would actually keep track of what we ordered to make sure we're only contributing that amount. Then at a certain point, everybody at the table becomes employed enough that a couple of bucks here or there doesn't really matter. And then the next level is you'll just be like, oh, I don't care, I got this one. When it's like friends. You know what I mean? But like when you're poor, you go to the restaurant, you're like, oh, I would just have a glass of water and another round of chips and salsa. Then the waiter comes back, says, well, you want anything? Haven't decided yet. Can we just get some more chips and salsa? Another glass of water. Then like an hour later, we're just stuffed on chips and salsa. Make sure you tip your server if you do that. You know what I mean? If they brought you chips and salsa all night, pay them for that. And don't be like, oh, well, 20% of zero is zero. You ask them to bring you chips and salsa all night, don't be a dick. Tip your server. All right. Anybody here work as a server? This is called the Decency Test. Has anybody here worked in retail? This is how I can tell that you have a chance of being a decent human being. You either work retail or a waiter in a restaurant. If you haven't done those things, there's a good chance that you're going to be a piece of crap when you grow up. Because everybody that's yelling at their waiter was never a waiter. They don't understand. You know what I mean? Everybody that's bitching at the retail employee doesn't understand. Anyway, that's the cross product and how to calculate it and what it represents. That's going to do it for today. I'll see you all on tomorrow. Everybody have a good day, and thanks for playing.